Class, and thank you for watching. Now, this is the review for the third quiz that we're going to have, which is going to be on Monday. So, again, quiz on Monday. All right. So, for the first problem right here, we have the absolute value of 8. So, to get the solution of this, that means that the value of b would have to equal to positive 8, or the value of b would have to equal to negative 8. So, your solution for this problem number 1 is going to be that. For number 2, you basically do the same thing. The solution for this would be positive 7, and the other solution would be negative 7. Now, as a multiple choice question, you'll see that the correct answer choice will be in this format. So you have that. Now for number 3, in order to get the solution, what you have to do first is solve this equation by subtracting the 8 from both sides, and negative 8 times the absolute value of x is going to equal to negative 8. You then have to divide by negative 8. This cancels out, and the absolute value of x is going to equal to positive 1. So now that you have, again, the absolute value isolated, this is where you could create the two cases. So again, in this case, the only x is equal to positive 1, and x is going to equal to negative 1. So this is going to be your solution. So for number 5, before you create the two cases, you're going to, again, have two answer choices. What you have to do first is you're going to have to subtract 10 from both sides. And the idea again is to isolate the absolute value. And this is going to end up with 30. You're going to then divide by 5. And the absolute value of x is going to equal to 6. So now that you have the absolute value isolated, this is when you create your two cases. So the absolute value of x is going to equal to 6, means that x has to be positive 6, and x has to equal to negative 6. So that's going to be your solution, which will be written like this, okay? Your answer choice will look like that. So for number 5, again, before we can solve this one and create the two cases, what we have to do first is get rid of this number right there, since it's being subtracted from the outside of the absolute value. So we would start by adding the 9 to both sides, and the absolute value of negative 8m will equal to positive 8. And now that the absolute value is isolated, we can create the two cases. So negative 8m will equal to positive 8, and negative 8m will equal to negative 8. So dividing by negative 8, we get that the value of m is going to equal to negative 1. And dividing by negative 8, we get that the other value for m is going to equal to positive 1. So these are your two solutions, negative 1 and positive 1. Now for number 6, again, before we can solve this absolute value, the first thing I have to do is get rid of this 1 right here. So I would have to add that 1 to both sides. And this cancels out, and we get that the absolute value of n minus 2 is going to equal to positive 7. So the way we solve this from here, now that the absolute value is isolated, again, now that it's by itself, this is when we create the two cases. The first case would be that n minus 2 is equal to positive 7, and the second case would be that n minus 2 is going to equal to negative 7. So adding 2 to both sides, you're going to get that the value of n is going to equal to 9, and adding 2 to these both sides, you're going to get that the value of n is going to equal to negative 5. So the solution to this system, or to this absolute value equation, is going to be 9 and negative 5. All right. So those two numbers are the possible values for n. All right, let's go to number 7. So for number 7, we are not allowed to distribute because of the absolute value, so I'm not allowed to multiply inwards. So what I need to do in order to have the absolute value by itself is I need to divide by 9. So the absolute value of 9 plus 4v, that's going to equal to 3. Now I can create again the two cases. 9 plus 4v is equal to 3, and 9 plus 4v is equal to negative 3. So to solve this, I first get rid of the number without the variable, so I would have to get rid of the negative 9, and we get that 4v is equal to negative 6. And now we would divide by the variable, by the coefficient, which is 4, and the value of v would be negative 3 over 2. When I reduce this, both of these numbers can be divided by 2, since 6 doesn't go into negative, 4 doesn't go into negative 6, but they do have a common factor of 2, so I can reduce it. Now for the other case, we would again still subtract the 9, and 4v will equal to negative 12, and when we divide by 4, the value of v is going to equal to negative 3. So that's your solution. V is going to equal to negative 1.5. In decimal format, the first one is negative 1.5, and the second number is negative 3. Okay. Now remember, this is not an interval. This is just telling you again the two different notations that we have, all right? The two different values for V. Now for number 8, we would have to do this the exact same way. Since we're not allowed to distribute, we would have to divide by negative 9. And the absolute value of negative 10 plus 4x is going to equal to positive 6. And now that the absolute value is isolated, this is when I could create the two cases. I could get negative 10 plus 4x and equal it to positive 6. And I create a second case, negative 10 plus 4x, but this time I equal it to negative 6. So for the first one, I would solve it by adding 10 to both sides. So 4x would equal to 16. And dividing by positive 4, you get that the value of x is equal to 4. Now for the second one, again, I would start by adding 10 to both sides, and 4x would equal to positive 4, and dividing by 4, we get that the value of x would equal to 1. So our solution will be written like this. The answer choice that you will be looking for will look like this: 4, 1. Now remember, again, these are going to be different. They're going to be different numbers, but the procedure, the way you're going to solve them is going to be the same, okay? So now for the next part, what we need to, again, make sure that we understand, again, is the symbol when we have the absolute value, the inequality symbol with the respective absolute value. So for this symbol right here, this is going to create an OR compound inequality. So for P, the absolute value of P is greater than or equal to 3. That's going to create two conditions. P is going to be greater than or equal to positive 3, or P is going to be less than or equal to negative 3. So just so you can have an idea of what that looks like as a number line, again, we have our endpoints, and you put them in order, least to greatest, from left to right. And above the positive 3, this one right here, we'll do this one first. We're going to have a closed circle, and look at the direction of the arrows pointing towards the right. So that means we're going to be the answers to the right. Greater than, so that's all the numbers to the right. Now if we look at the other one, this one right here, that is going to have a closed circle as well. And this one has the inequality pointing to the left because that's less than. So all the numbers to the left, less than negative 3. And again, that correlates to having an OR compound inequality. Now, the way the solution is going to be on the quiz, however, it's going to be an interval notation, as it says right here. We want to write the solution in interval notation. So the way we're going to represent this answer is in the following form. We say that our solutions are all the numbers from negative infinity to that first endpoint, and we will use a bracket because we are having a closed circle, or all the solutions for P would be the numbers from positive 3 all the way to positive infinity, okay? So you'll be looking for that. So our quiz again is going to be multiple choice. So you have, again, so that means that this would be one answer choice. The other possible answer choices are going to look like this. So this one would be the right one. And this one would be incorrect because the absolute, I'm sorry, because of the, let me use a different color. I'm sorry there. Let me use this one here. So this, because of these, because of the parentheses. It should be brackets because of the closed circles, okay? The other possible answer choices would be -3, well, that should be -3 to +3, and with the one that looks like bracket. These are incorrect because these are for the and compound inequalities. The graph of this will go from -3 to +3, but it would be an open circle, first of all, and the lines would be towards each other. You would connect the two endpoints. And the difference between this last one and the third one, the only difference between the top one with this one right here is that this one will have closed dots, but all the answer choices would be like that. So this one would be wrong, this one will be wrong, and the correct answer choice would be that one, the very first one, all right? So the one I did at the top. So again, this is just to explain to you how the answer choice, what to expect on the quiz, and in terms of the answer choices, what they're going to look like, all right? So make sure you know, first of all, the difference between having an or and an and compound inequality that's created with these absolute values, inequalities. And second, understand the difference of when we're going to have brackets, or we're going to have these brackets here, okay, and the parentheses. And the reason why, because again of the closed circles. So for number 10, for this one here, since now the absolute value is less than 1, this less than means we're going to create an and compound inequality, all right? So that means that we're going to have two endpoints, and we're going to connect those two endpoints together. We just need to figure out what these numbers are going to be right there. Also for this one right here, since the n is the only thing inside there, we say that n is less than +1 and n is greater than -1. So from -1 to +1 on a number line, we would have two open circles this time because there's no equal sign with the inequality. Again, it's just less than. And the direction of each one would be the following. For this one right here, for the first one, this is pointing to the left of +1. So on +1, we're going to go to the left. And for -1, notice that we're going to the right, greater than, so to the right. So it's only going to be the solutions, again, that are found in the middle. So it's only going to be these numbers right here in the middle. So it will look like this. And as an interval, the way that you're going to look for the answer choices is in this form. It'll go from -1 to +1, and we would have to use parentheses. So for number 10, you'll look for an answer choice that looks like this, okay? Or number 9 and 10, you'll look for the answer choices that look like this. But again, everything's going to be in interval notation. For number 11, to be able to create the two conditions, what we need to do first is eliminate, again, the operations being performed on the outside. So I need to get rid of those two numbers right here. So the first one I have to get rid of is the 10. I will subtract it. And I get that -2 times the absolute value of n will be less than or equal to -12. We will then divide by -2. And the values of n, the absolute value of n, is now going to be greater than or equal to +6. So I switch the inequality because I'm dividing by a negative, so remember that. So for this one right here, and only if I divide by a negative do I have to switch it. If I don't divide by a negative, I don't have to switch it. It stays the same. So since the inequality is pointing in this direction, this is going to create an or compound inequality. So the values of n have to be greater than or equal to +6 or the values of n have to be less than or equal to -6. So as a number line, as a graph, -6, +6 would be in that order. Above the +6, we would have a closed circle, again, because of the equal sign, and the inequality is pointing to the right, greater than. And for the -6, this is also going to have a closed circle, but that's less than, it's pointing to the left, so it would be pointing in opposite direction. So again, this is an example of an OR compound inequality. So our solution in interval notation would look like this. Oh, well, I need to fix this with the exception that it should be brackets instead of parentheses because of the closed circles. So this is the solution. This is how your answer is going to be represented and the answer choices. Now for number 12, we'll do the exact same thing. In order to solve this absolute value inequality, we have to do first is isolate the absolute value of n. So I want this to be by itself. So to do that, I have to start by subtracting the 7 from both sides. And 10 times the absolute value of n is going to be less than or equal to 80. We divide by 8. And the absolute value of n is going to be less than or equal to 8. So we could create the two cases. N is going to be less than 8. N is going to be greater than or equal to -8. Remember that switches, the two cases switch. So before we draw the interval and write our answer in interval notation, so we have an understanding whether we're going to have an and or an or in case you, again, forget which one is which. Simply draw the number line and you could then do this. For +8, we would have a closed circle, as you see right here, and the direction of inequality is pointing to the left, less than. And for the -8, we would also have a closed circle, and that one is pointing towards the right. So one's pointing to the left, the other one's pointing to the right, so that means that the solution is only going to be the numbers in the middle. So this is an example of an and. Again, this created an and compound inequality. So all our solutions are going to be in the interval from -8 to +8. And this time, compared to the previous one, to the one on top, number 10, we now use brackets and not parentheses. So this is the way we're going to represent it because we have now closed circles right there. Now for number 13 and 14, we're not going to allow to distribute, so we cannot multiply this with 4. So the way we do this problem here is that we have to divide by 4 so we can isolate the absolute value. So this is what we end up getting. So now with this, we are now going to create again the two conditions. We can create the two conditions. We get again what's inside the absolute value, which again is that. So we get this 7n minus 1 and have it be less than 22. And then we get the again same thing, 7n minus 1 and have it be greater than -22. So solving the one on the left, we would have to add 1 to both sides, and 7n is less than 23. We will then divide by 7, and the value of n would be less than 23 divided by 7. I'm going to leave it as a fraction, not write it as a decimal value. So now the one on the right, we would again add 1 to both sides, and we will get 7n is greater than -21. And dividing both sides by 7, the value of n would be greater than -3. So let me zoom out a little bit. So as a number line, I'm going to draw the number line over here. The negative value is obviously smaller than the positive value, okay? We're going to have open circles on both of them, again, because there's no equal sign, as you see right here, no equal sign. And for the first one, this one right here, the arrow is going to be pointing towards the 3, to the left, less than. And for the -3, the arrow is pointing to the right, greater than. So you see the solutions are going to be simply only the numbers in between. So this right here created an AND compound inequality. So our solution in interval notation would simply be -3 to 23/7. And we would use parentheses again because we have open circles. Now for number 14, moving along to number 14, this again we cannot distribute like I mentioned earlier. So what we do is that we divide both sides by 2 this time, by that number right there. So that way these cancel out and we end up with the absolute value of 3k minus 6 is greater than 18. So we're going to solve this by now doing the following thing. We create again the two cases. We get first at 7k we get that 7k minus 6 and have it be greater than the 18. And then we get this at 3k minus 6 and have it be less than negative 18. So remember, you keep, change, switch, and switch. All right. So now that we have again the two cases, this is where we can actually continue solving it from everything on the inside. So for the one on the left, we'll start by adding 6 to both sides, and we get that 3k is greater than 24. We will then divide by 3, and the value of k would be greater than 8. We add, on the one on the right, we would do the same thing, add 6 to both sides, but this time we end up, since it's negative 18 plus 6, that's going to give us negative 12. We divide by 3, and the value of k would be less than negative 4. Now, in case you had forgotten, again, because I kind of just went over that, this again creates an OR compound inequality, all right? But again, it's going to match up perfectly, as you'll see right now. So if I create a number line and I put my numbers in order, -4 being smaller than 8 will go first. Above both of them, we would have open circles, and on the 8, since this inequality here is pointing to the right, greater than, we will go to the right. And on the -4, this inequality is pointing to the left because that's less than. We will go to the left. So we would end up again with the graph looking like this, as you see. Now, as an interval notation, that's represented in the following form. That all the solutions are going starting from -infinity to -4, or all the solutions are going to go from 8 all the way to positive infinity. So this is going to, again, like I said, create an OR compound inequality. So you have to, again, be familiar with when you have an OR or an AND compound inequality. But again, you cannot distinguish that until you have the absolute value isolated, like I've done right here. Notice again, then on these last four, 11 to 14, I had to first isolate the absolute value, and then I could create the two cases. On numbers 11 and 12, I had to subtract and then divide. On the 13 and 14, I just simply had to divide to get rid of the leading coefficient of getting rid of that number on both of the examples. Now, moving on to the back, the number 15 and 16 are probably going to be the easiest ones other than numbers 1, 2, and the inequalities, numbers 9 and 10. These are going to be simply because all we're doing right here is that this notation means that we are going to substitute in this case, the t value with 6. So k of 6 means that we're going to get 2, multiply it with 6, and add 1. Well, this is 12 plus 1, so the answer is 13. And number 16 is the exact same thing. Finding w of 6 means that we're going to replace the t. The t is going to be the 6, so we're going to replace the t with 6. And all we're going to do right now is just subtract them. 6 minus 4, I'm sorry, 6 minus 2 is 4. All right, 6 minus 2 is 4. So that's going to be your solution for number 15 and 16. And then finally to the systems of equations. Now for the system of equations, again, the key idea of using this technique of elimination is that you have to have your variables lined up, okay? And we need opposite numbers. For number 17 is going to be the easiest one of these four sets because all you have to do is simply add downwards and one of the variables is going to eliminate it. Here we pay very close attention. You're going to notice that the x's have opposite coefficients. So adding two opposite numbers is going to make this equal to 0. So 5 plus negative 5 is 0. Adding everything else, we end up with positive 4y. This is going to be negative 16. And then we divide by 4, and we find that the value of y is negative 4. Now, to figure out the value of x, what we need to do is using the top equation. So I'm going to write the top equation, 5x plus 10y is equal to negative 30, or the bottom one, doesn't matter, really matter. I'm going to substitute in the number negative 4 into the value of y. So 5x plus 10 gets multiplied with negative 4, and now that's going to equal to negative 30. So 5x minus 40, multiplying these two numbers together, that gives me negative 40 is equal to negative 30. And I solve this two-step equation. I add 40. That is 0. I bring down the 5x. Negative 10 plus 40, that's equal to positive 10. Negative 30, I'm sorry, negative 30 plus 40, that's equal to positive 10. I divide by 5. And x is equal to 2. So there's your solution for x. So the solution overall is going to be the x and the y value. So the answer choice that you'll be looking for, again, is going to be written like this. So it's not going to be written separate. It's going to be written as an ordered pair. So make sure that you write the numbers in order, x and then y. Don't flip them around. For number 18, in order to use this process of elimination, adding is not going to be enough because they are not opposite values, all right? So if I add going downwards, nothing gets eliminated. 4 plus 1 is 5, 6 plus 6 is 12. So what I need to do before I can actually add these is that I need to multiply one of these things by a negative, because as you see right here, this 6 and 6 are both positive. But if I had one of them be negative, adding opposites, one positive, one negative, opposites of each other, adding them together would again eliminate one of those things. So we're going to keep the top one the same. The top one is not going to change. So that's going to stay as 4x plus 6y is equal to 8. And the bottom one is going to become negative 1x, a negative 6y, and negative 11. Now I can add going downwards, and the y's will eliminate because now they're opposites of each other. 6 plus negative 6 is 0. So adding 1 and negative 4 plus negative 1, that's 3x. Adding 8 plus negative 11, that is also going to be, well, negative 3. And then when we divide both sides by this positive 3, x is going to equal to negative 1. Now finding the value of x is, now to find the value of y, I'm going to use the top equation like I've been doing on every single one of these examples and all these lessons. And I'm going to substitute in this number, negative 1, and for the value of y. So we have 4x plus 6 times negative 1 is equal to 8. And multiplying 6 plus 6 and negative 1, we end up with negative 6. So multiplying those two, we get with negative 6. And then we solve this using, again, our 2 method. So we start by inverse adding 6. We're going to end up with hold on. What did I do wrong? 4x plus 6y is equal to, oh, yeah, sorry. Hold on, that's not right. Thought I had solved the equation for y. I didn't. Look, we had solved the equation for x, so I'm plugging it into the wrong place. I'm sorry, guys. So I should be plugging it into the x and not the y. So that's why the answer was looking, okay, that's not, it's going to work. So plugging in -1 into the x there, that's going to fix that. We'll multiply that, so that's -4. Now to solve this, we would have to add the 4 first before we can divide. So this becomes 0. We have 6y is equal to 12. And when we divide by 6, we get that the y value is 2. So our solution is -1, +2. For number 19, this is when it gets a little bit more complex. Notice that none of the numbers are opposites of each other. We do have a negative sign and a positive sign right here, but 5 and +6 are not opposites of each other. So adding is not going to eliminate that. And 2 plus 3, that's not going to become 0 either. That doesn't get eliminated. So the trick for this example here is to eliminate one of the variables. I'm going to decide to get rid of the x terms. So to do that, I'm going to multiply the top equation by 6 and the bottom equation by 5. So the common multiple is 30, and I end up with opposite values. So the top equation multiplied by 6, that's going to give you -30x, +12y, and +84. Multiplying the bottom equation by 5, that's going to give you +30x, +15y, so +15y, and -30. And look at this. This right here, these two numbers are opposites of each other. So now, if I add going down, this -30 and this +30 becomes 0, and that gets eliminated. 15 plus 12, 12 plus 15, that's going to equal to 27y. And 84 minus 30, that's equal to 54. So dividing both sides by 27, you get that the value of y is going to become +2. So using the top equation, -5x plus 2y is equal to 14. Let me make sure I don't make the same mistake as the previous one. I'm going to replace the y value with 2. So -5x plus 2 times +2 is equal to 14. Multiplying 2 and 2, we get a +4. And inverse operation, we would have to subtract 4. And we get that 5x has become 0. Then we get, bring that down, we get that -5x is going to equal to 10. So dividing, we would see that the value of x has to be -2. -5 times -2 is 10. So here's your x value. Let me use the color red. So our x value is -2, our y value is +2, and that's going to be the solution to the system. And for number 20, all we have to do before we can solve this is rearrange it, all right? So here, I would have to put the x first, so I'm just going to flip the order of this. And I'm not going to change the sign, I'm just going to read this from left to right. So I'm just reading it from right to left, from right to left. So 2x plus -4y, which is -4y, is equal to 8. But the one on the bottom, I have to do some rearranging. I have to add this one to the other side, so move it to the other side. So I have the 2x is okay, but I'm going to move the y term to the left side. That's going to make it +3y. And I need to move the constant and the -8 to the opposite side. So I would have to add that, and that would make it +8. So from here, notice that the 2's would eliminate if only one of them was a negative. But since they're both positive, adding them will not eliminate any of these. So I'm just going to simply multiply by that -1. So that will fix that, and that's an easy trick for there. And we would end up with -2x negative 3y is equal to negative 8. So now if I add, now that I have one positive 2x and one negative 2x right here, if I add those two things, that's going to become 0. Adding everything else, we get negative 7y is equal to, well, 8 plus negative 8, that's equal to 0. Now, I did notice that some of y'all wrote on this case when we eliminate the constant that there would be no solution. But no, there is a solution here. Here we can solve for this because if we divide by negative 7, y is going to equal to 0. So that doesn't mean that there's no solution. This simply means that the value of y is equal to 0. So to figure out what the value of x is, I'm going to pick the top equation, again from right here, this 2x minus 4y is equal to 8, and I would replace the the y value with 0. And we will get that 2x minus 4 times 0 is equal to 8. 2x, well, 4 times 0 is 0, so I could basically ignore that term. So 2x is equal to 8. Having it equal to 0 is not going to make much of a difference because if I add 0 to both sides, I'm still going to get that 2x is equal to 8. So 2x is equal to 8. So when we divide by 2, x is equal to 4. So the solution to this system here is going to be 4, 0. Now this last one would probably again be the most difficult one of the 4 on this section here. Number 20, because again, you're going to have to manipulate the equation and rearrange the variables. So you have the x, the y, and it's equal to the constant. You will then have to maybe multiply one of them by negative, or if not, something will probably be the opposite. Try just simply adding down and see if something gets eliminated. Okay, and if that doesn't work, then you just have to make sure that you have opposite numbers for one of them. Okay, well, thank you again for watching. Now, again, for watching this, I'm going to reward you for 10 extra points on your quiz. But to prove that you actually saw this video, I need you to write the following code on the top of the page, right here, right next to your name, okay? So I want you to write this code. Let me put it in black. I want you to write P, T, Y, G, U, N, the number 5, and then the letter J. Okay, so write this again next to your name or to somewhere on the top of the page. Okay, somewhere right there. Please make sure again to include your period. Some of you are now writing the period on your assignments. Please make it a habit of writing again the period on the assignments. I have many people with the same first names, and you forget to write your full name, and I have to again look around and see whose paper that is. So if you do me a favor again, making sure you write first of all your full name and the period that you're in my class. All right, that'll help a lot. Well, again, thank you for watching and continue studying. Bye.